All right, we're going to just get right into it today. We're dealing with more triangles, and this time we're going to start off with a conjecture, the triangle inequality conjecture. So take your conjecture sheet out, write this down. We'll talk a little bit more about why this is true in class. So the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So what that means is that if I have this triangle where one side is 15 and one side is 10, the x, that third side, has to be less than 15 plus 10. If that third side is bigger than 15 plus 10, it doesn't work as a triangle. So x has to be less than 25, whatever your unit of measurement is. If x is greater than 25, what happens then is we try to create that third side, but we get something like this. Okay, so we can't have a triangle where the third side is bigger than the sum of the other two. So knowing that, is it possible to have a triangle with these side lengths? So if I have a 6 centimeters, 7 centimeters, and 3 centimeters, we have to take all the possible combinations, because remember it said the length of any two sides. So let's just start in order and say, okay, well, is 6 plus 7 greater than 3? Well, that's true, so that triangle works. All right, but then I have to do another combination. Let's say 6 plus 3, so now I'm using 6 and 3 as two of the sides. That also has to be greater than 7. Is that true? That's also true. I still have another combination. What about 7 and 3? So if those are two of the sides, that must be greater than the third side, which is 6. So 7 plus 3 has to be greater than 6. Is that true? Yes, that is also true. Okay, if I want to sketch this, I'm just going to say 6 plus 7, so that's a little bit longer, and maybe that doesn't really look real good, does it? How about 6, 7, and 3? So that triangle works. Well, let's try the same thing with this one. So again, all three combinations, 6 plus 4, must be greater than that third side of 1. True. All right, what about 6 plus 1 greater than the third side of 4? Also true. But now I have 4 plus 1, and I'm using these two. Those two sides have to be greater than the third side of 6. Now, is that one true? Well, 5 is not greater than 6, so that does not work. I cannot make a triangle out of those three side lengths. All right, let's skip C for now. Let's do the easy ones without the decimals, and we'll do some with decimals in class. So is this one true? So we really have to just do the first one. 3 plus 2 needs to be greater than the third side, 5. 5 is greater than 5? Doesn't make sense. That does not work as a triangle. I cannot make a triangle out of that simply because 5 is not greater than 5. Okay. So I'm going to go a little bit further here. I don't have a third side. What are my possible values for the third side? Again, if you think in those three different combinations, and I do that again, 8 plus 3 must be greater than x, so there's 1. And then I have 3 plus x must be greater than 8. And I also have 8 plus x must be greater than 3. So if I look at those three things, let's simplify those a little bit. So this one says 11. Oops, that should be an x. So first of all, let's bring that down here. So I have x is less than 11. I'm just flipping it around. Right, if I solve this one, subtract 3 from both sides, I get x is greater than 5. So I'm going to record that down here. And then on this one, if I subtract 8 from both sides, I end up with x is greater than negative 5. Well, that really doesn't make any sense. With a triangle, we can't have negative side lengths, so I'm going to stick with these two. And what do I get? If I put these together, so I said x has to be greater than 5. So 5 is sort of my start value, and 11 is my greatest value, so it must be less than 11. So the possible side lengths are going to be between 5 and 11. All right, let's do another one. We'll do one more. We'll do more practice with this in class. All right, so again, if I take all three combinations, 65 plus 15, those two sides have to be greater than the third side y, right? So that if I go ahead and simplify that right away, right, I have y is less than 80. Okay, let's do the next one. Now I have 65 plus y has to be bigger than 15. If I subtract 65 from both sides, notice I get a negative, so I don't need to worry about that one. And then I have 15 plus y has to be greater than 65. If I subtract 15 from both sides, whoops, let's circle that, there's my answer for that one. If I subtract 15 from both sides, I'm going to get y is greater than 50. Let's record that down here. So now I have y is less than 80 and greater than 50. So I'm going to put that in a range of values. That's going to be my start value is 50. My maximum value is 80. So y has to be bigger than 50 and less than 80. So that's how I'm going to find the range of values for a missing side. Okay. So here's another one. If we're just talking about isosceles triangles, if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. Remember that from before, right? So when we talked about isosceles triangles, these angles have to be congruent because these two sides are congruent. So if I know that that last angle is 38, it's a little review from yesterday, or from the other day. So if I take that and I go ahead and subtract, okay, I have 142 degrees remaining. Well, 142 degrees split between those two angles is going to give me 71 degrees apiece. So remember that, please, for isosceles triangles. But then we have another inequality conjecture. So make sure you're writing these down again on your conjecture sheet. In a triangle, if one side is longer than the other, then the angle opposite the longer side is greater than the angle opposite the shorter side. So again, if one side is longer, so let's say this side is 10, this side is 8, and I go ahead and complete that triangle, what we're saying is the angle opposite the longer side, so this angle right here, we'll call that angle A, right, and we'll call this one angle B. The angle opposite the 10 is bigger than the angle opposite the 8. So A is greater than B in this case. So again, the angle opposite the longer side is greater than the angle opposite the shorter side. Now, in a triangle, if one angle is larger than another angle, so if you kind of look at it the other way, then the side opposite the larger angle is, same idea as above, longer than the side opposite the smaller angle. So really, I'm just taking this right here, and if I think about that backwards, so let's do another triangle. So now if I have same triangle, but I know the angle measurement. So let's say this is 30 degrees, and this one is 45 degrees, and I call this A, and I call this B. Well, which side is longer? A is the longer side because it is the larger angle, okay, because it's opposite the larger angle. So that's what we mean by that. And so if I take a look at a couple of these examples, if I want to order these from least to greatest, my angle measures, what would be the smallest angle? What would be the largest angle? If I take my smallest side, that's going to be my smallest angle. So C is the least, right? What's my next? That's the next shortest side, or the next longer side, I should say. So I have A would be my next larger angle. And then finally, this is my largest. So my largest angle would be B. So in order least to greatest, I could say C is less than A, which is less than B. All right, so that might be a way to say that. So now in this one, I have two angles, and I want to know what the order of my sides is. So from least to greatest, what's my shortest side to my longest side? right, well, first we might want to know that third angle, right? I have 115 degrees and I have 27 degrees, which is going to give me, you can go ahead and take out your calculator, right? I have 142 degrees total. So that remaining angle is going to be 180 minus 142. So that remaining angle is 38 degrees. So least to greatest, what's the order of my sides? Well, opposite the smallest angle is C, which would be the least. The next then would be this one. So I would have A. And then finally, my last one is going to be B. So C is less than A, which is less than B, would be the order of my sides. Right? It only works for one triangle at a time, so I'm not going to go through and try to figure out all of the side lengths for these. If I go through and try to do this, let's take a look at how this works. If I know this is 90 and this is 60, it gives me 150, and that's going to be 30, right? So if I look at that bottom one, I'm going to say, let's see, opposite the smallest angle would be A. So I would have A, right? A is the least. So A is less than, the next one would be B, because that's opposite 60. And so finally I would have C. A is less than B, which is less than C. Now if I try to go through and do the other ones, I have 70, 80, and again 30. I'm going to say, okay, C is the least, but wait, over here C is the greatest. I'm only going to do this one triangle at a time. So don't try to do this when you have a bunch of triangles put together. Okay, it only works for one triangle at a time. All right, a couple other things and then we're going to be done. So I know this is kind of a longer one, but just bear with me. So something we need to know also about the exterior angles of a triangle. So you look at this image here on the right-hand side, we've been dealing with these angles, right? But there are also, those are interior angles. But then I also have something like this. This would be called the exterior angle. All right, so draw this diagram, please, and label exterior angle. Also label remote interior. And, whoops, I'm uncovering some text here, which I don't mean to do yet. And then I also have adjacent interior angles. So let me go over those real quick. So exterior is just simply on the outside of the triangle. It's an extension of the interior angle, right? That's your exterior. Remote interior angles. Your remote interior angles are going to be the angles that are not connected to this right here. Right? Those are your remote interior angles. They're the angles that are not connected to your exterior angle up there. All right? So remote, we're looking at the angles that are not connected. Okay, and then finally we have our adjacent interior angle. Well, if this is our exterior, adjacent just means next to. So the adjacent interior is next to the exterior. All right, so those are some terminology you're going to want to know. All right, so now let's see what we've got here. Now you can copy down those. Vocab words. I don't think I have one more up here, so let's look at that one. All right, so there's your vocab. So we have an exterior angle outside of the triangle, adjacent, inside, and next to the exterior, and remote inside the triangle, far away from or not connected to the exterior. Remote just means far away. All right, so those are your terminology when we're talking about the angles of a triangle. All right, last one. All right, so the measure of an exterior angle of a triangle, exterior, okay, so the measure of an exterior angle of a triangle is equal to the sum of its remote interior angles. So what do I mean by that? Looks like I need to scroll down a little bit here, don't I? All right, so I have the sum of the exterior angle is equal to the remote interior angles. So if I have 140 degrees right here, what we're saying is that is equal to 85 plus whatever that other angle is, plus whatever x is. So if I know that that exterior angle is equal to the angles that are far away from it, the interior angles that are far away from it, I can find out what x is. If I go ahead and subtract 85 from both sides, again, you can use your calculator, go right ahead. I know now that x is 55 degrees. So that's another way to find the third angle of that triangle, or the other angle of the triangle, okay, by using that using those remote interior angles. So let's take a look at this one. Right, notice this is isosceles, so if that one is p, then this one is also equal to p. Right, so I have those remote interior angles are equal to, or the sum of those are going to be equal to that exterior angle. So those two angles together must equal 150 degrees. In other words, 2p equals 150. And if I divide 150 by 2, I'm going to get 75 degrees. So I know that each of those angles is 75 degrees. And today we are going to stop there.